Dear students, welcome back to my class. So today we are starting with the topic formulations of theories and laws in science. Here we are generally discussing about the three terminologies associated with this topic. That is what is meant by scientific evidence, scientific proof and peer review. We know that a theory is an organized set of reasoned ideas which is intended to explain facts, phenomena and events. Comparing with a hypothesis, theories are much more accurate as well as stable. We know that scientific investigation is an ongoing process, so this kind of theories may be subjected to revisions from time to time to bring them into a conformity with new findings. So as it has to be, the theory has to be modified or has to be revision, we need to repeat the experiment. So how it is possible? That is we are discussing in this paper. Okay, so let's move to the detail of each one. What is meant by scientific evidence? A scientific evidence is a fact or figure which is useful for supporting, opposing, substantiate or even invalidate a hypothesis, theory or law. So scientific evidence is nothing but it's a facts or figures. Here, these kinds of evidences are collected through experience as well as observation by means of experiments. We will get these facts and figures by means of experience or experiment. And after the experiment or observation is over, we are symmetrically arranging these evidences for investigation. And as a result of investigation, we will get a result. We are based upon this result, this hypothesis may be accepted or rejected. So this is called a scientific evidences. Those evidences or those figures or facts which is very essential for supporting a theory or hypothesis or a law is called a scientific evidence. The next topic is what is meant by scientific proofs. A scientific proof is a logical deduction or it is a process of reasoning used for establishing the truth. For establishing a truth in our experiment, we need to make some kind of reasoning. This is generally done by means of scientific proofs. And here we are making the scientific proofs based upon the acceptable assertions or proved inferences. If the assertions that we are making becomes true or proved, we can say that this will be a thesis. And the inferences on which this proof is built and the rest of the thesis is called arguments. And these arguments must be true or false based upon the established facts. If the thesis becomes true, we can say that this is a simple proof. And if the thesis is rejected, we can say that this is a refutation. So that is meant by scientific proofs. Proofs have generally possess some features which actually does not exist in science. And this scientific features are generally two different types. That means the proofs are final and they are binary in nature. That means either true or false. This true or false condition is generally applicable to mathematics only. Okay, the rest of the scientific investigation, this binary concept is not much acceptable or applicable. Okay, so that is mean by that is called what scientific proofs. Then comes what is mean by peer review. Peer review is concerned with the expert scrutiny of the result of a scientific investigation. If you are analyzing much more in a core way, we can say that we need to investigate this observation. So this expert scrutiny of the result done by a team of researchers in a scientific investigation is called a peer review. And for this peer review, we require a team of scholars which are competent for quality assessment. This peer review generally encourages the authors for maintaining a standard work. It helps to avoid irrelevant findings, unwanted claims, unacceptable interpretation, etc. And this peer review is the most effective method for making a work a perfect, flawless and error-free. So that's all about these three terminologies mainly associated with what? This formulating the theories as well as laws in science. So I hope you understood. If you have any doubt, please do in the comment section. Thank you.